so here are some notes on systems of equations, and specifically, we're going to go over graphing first. So the first thing you got to know is what is a system of equations. And what that is, it's two or more equations where the solutions are true for all of them. Solution. So basically, we're back to solving for x and stuff like that, but now you need to be able to solve for an x and a y, and it's got to work for more than one equation. So we're going to do this by graphing first. And kind of how this works when we're graphing, it's pretty simple. We're looking for where two graphs meet. Or more. So if I ask you to solve something by graphing, you're simply just going to graph both of them, or all three of them, or all four of them, and see where they meet. I don't know why I wrote a C with 3 E's, but whatever. So I might ask you to solve y equals 2x minus 1, y equals negative 3x plus 4. So what we're doing is we need an x and a y that works for all of that stuff. So hopefully you remember how to graph, but if not, I'm going to give you just a quick review. All right. Oh wow, I missed that. Oh, we're not going to need that side anyway. So, in case you forgot, y equals mx plus b. M is slope. Which is rise over run. B is the y-intercept. So if we're going to graph y equals 2x minus 1, you look for what we call the lonely number, that's the y-intercept. That's where you put your first dot, minus 1. 2. And what you've got to remember is 2 can turn into 2 over 1, so that means go up 2 over 1. And then you would draw, and if you guys were doing this, you really should be using a ruler. There's our line. Now if we want to draw this next one, the lonely number is positive 4, so you go 1, 2, 3, 4, then down 3 over 1. 1, 2, 3, 1. And we see it crosses at the dot 1, 1. So there's a couple different ways you can write your solution. You can just write 1, 1. You can also write x equals 1, y equals 1. So why is this a solution? That's because it should work for both equations. So we should double check. We can plug them in, right? And this is going to be true for everything we do. And you have to get really used to plugging things back in. So y 1 equals 2 times 1 minus 1. 1 equals 2 minus 1. Check. That's true. Now let's try the other one. 1 equals -3 times 1 plus 4. 1 equals -3 plus 4. Check. So that solution worked for both of those things. And that's what makes it a system of equations and not just solving an equation. Because we could have found a solution to this because said, oh, look, y equals 2, x equals 2, y equals 3. Then if we tried plugging it back into this equation, it wouldn't have worked. So we're looking for the solution that works for everything. Okay, that is very, very important. Otherwise, it would be simple. We would just solve one thing and it would be good. And yeah, that's really it for system equations and solving by graphing. Let me just note before I forget, the drawbacks is that it's hard to be precise. You need a ruler and an even graph. So like my things, those lines are probably not exactly the same distance apart, which means if I would have given you a slightly more complicated graphing problem, it would have been off. Yeah, and that is it.